Hello my dear students, once again most welcome back in my YouTube channel, that is Physics Learn. Today I am going to teach about the principle of superposition. Okay, by using the principle of superposition we have to learn today how to derive the some numerical based question. Okay, in the previous classes we have already learned about the statement of Coulomb's law. Okay, let's discuss about the principle of superposition. That is, we have to take nth number of charges in a system, right? Then force on any one charges is the vector sum of all the forces due to remaining charges, right? Here I have written over here, in a system of n charges, the total electrostatic force on any one charge is the vector sum of forces due to all remaining charges on these charges. Suppose we have to take nth number of charge, right? Here is Q1, Q2, here is Q3, suppose here Q1. Suppose here Q1, force on Q1, right? Then vector sum of force, that means this force will be add over here, this force also will be add over here, and this force also will be add over here, right? That means here n in a system of n charges, the total electrostatic force on any one charge is the vector sum of forces due to all remaining charges. Suppose any one charges we can assume, right? Q1 को हमने लिया एक चार्ज, ठीक है? इस Q1 पर जितने भी टोटल फोर्स लगेगा मीन्स दिस वन force on Q1 due to Q2, due to Q1 and due to Q3, right? That means here force, net force, here is force, net force on n charge equal to the force on n charge due to 1, right? Force on n charge due to 1 charges, similarly plus force on n charge due to 2 plus force on n charge due to charge number 3 plus dot dot dot, here F on n charge due to n minus 1 plus F on this much only, okay? This much. How? कैसे? फोर्स जो लग रहा है n चार्ज पर ड्यू टू दिस चार्ज, राइट? ड्यू टू वन चार्ज, इसी प्रकार से फोर्स ऑन n चार्ज ड्यू टू चार्ज नंबर 2, इसी प्रकार से फोर्स n चार्ज पर लग रहा और इसमें ड्यू टू Q3 चार्ज, राइट? दिस इज द प्रिंसिपल ऑफ सुपरपोजिशन, ओके? Net force of n charge equal to this one, okay? Vector sum of forces due to all remaining charges. This is our final expression, that is like this we can write over here, net on n charge equal to F n1 plus F n2 plus F n3 plus finally F n into n minus 1. This is our principle of superposition. Okay, and next we have to solve some numerical based question, right? Let's some polygon based questions. Okay, here questions. Question number 1. Suppose we have to take one equilateral triangle. This is equilateral triangle. Here is plus q charges, here is plus q charge, here also plus q charge, and name them A, B, C vertices. Find the net force. Find net force. Net force. Net force on charge at vertex C. Here asking the find the net force on charge at vertex C. Right? Here how we have to find A, B, C in equilateral, each side is A, each side is A. Right? Net force, that means force will be act due to A and due to B vertex. Right? That's a force on C due to A here equal to our by Coulomb's law. There is plus Q charge, there is also plus Q charge. Here force will be this side because this is the line charges. Plus Q it will be repel. That's a force on C due to A. Okay. Then another force will be add force on Q, force on C vertex due to B vertex. Then direction of the force will be this side. Force on C due to B. Okay. Here force, that means K. Okay. Here charges, that means Q into Q square divided by distance. How much? A square. Our Coulomb's law was this one now. F equal to K Q square divided by R square. R was the distance. Then our distance over here A. Right? Similarly, force on C due to B. Due to B. Then K Q into Q square divided by A square. Here is magnitude, both are same, that means F we can see. Right? Resultant force between this one, that's a, this will be 60 degree. Okay? Then resultant will be this side. Okay? Then here we have to use by using the principle of superposition. Right? Our principle of superposition, net force, here force on vertex C on C equal to root over our force on CA square plus force on CB square plus 2 FCA into FCB into cos theta. Here theta is 60 degree because it is the equilateral triangle. That's why this is 60, 60, 60. That's why our net force will be force on C equal to our, suppose magnitude of force on C due to A and similarly both are same. Right? A equal to K Q square by A square. Same over here. FCB equal to K Q square by A square. That's F. That means we can put in place of this one, that is F, and this in place of this one, that is F. That's why our equation will be F square plus 2 into F into cos 60 degree. Cos 60 degree. Then our root over F 2F square plus 2F square into cos 60 degree. Value of cos 60 1 by 2. Okay. Then 2 is is going to cancel out. That means here is the 3f square. 3f square. Then this square of this f is going to cancel out this one. That's f root 3. This is the net force on C charges, right? And we can write the final answer if resultant force or net force equal to value of f equal to this one. We can use kq square divided by a square root 3. This is the answer. Similarly, we can solve another question. Okay, let's complete this one. Okay, next. Second question I am giving. This is equilateral. This is A, B, C. Here is the plus q charge. Here is minus q charge. Here is plus q charge. A, B, C. Same, find the net force on charge at vertex C. How we have to find? Here, force, its distance is A, right? Force at C. Force on C due to D. Then here is the unlike charges. That's the direction will be this side. Okay, it will be attract F C due to D. Okay, and force on C due to A, the direction will be this side. Direction of the force will be this side. Force on C due to A. That means our figure is making like this. Okay, this is this direction, that is F C A, and this direction F C B. Okay, making how much degree? 60 degree. Like this, making the graph. Okay, then our force on C due to B equal to our k q square divided by a square. Okay, and force on C due to A equal to k q square divided by a square. Both magnitude are same. That means we can assume the F. Then by using the principle of superposition, then force on net force on C equal to our root over this square, that is f square plus 2f into cos 60 degree. Answer becomes same. Okay, then our root over f 2f square plus 2 into f square into 1 by 2. That means this is going to cancel out. Then root 3. Same answer will be coming. Net on vertex C. C equal to 3 root, f root 3. This will be the answer. Okay. I hope you have to clear like this type question. Okay. Next question. Our next question, question number 3. Right. Suppose given the charges in a square form. Here is A, B, C, D. Here is plus q charge. 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 Okay. Here its distance is A. All sides are equal in a square shape. Okay. Here ask the find the net force. Find net force on charge at vertex C vertex. That means here we can observe over here force. There is acting 3 charges. Force will be at 3, right? Force on C due to this one. Okay, direction will be this side. Okay. F C due to B. Direction of the force will be this side due to this charge. Because this is light charges, that is force on C due to D. Yes. Then one force is there, this one. Okay. Force on C due to A, this one. Direction will be this side. Force on C due to which one? A. For this one, first we have to find the resultant between this force to this force. Right? This is 90 degree. Here is the 90 degree. This is the 90 degree. All angles are 90 degree in a square. Okay. Then our force on C due to D equal to our Q square divided by how much? Distance is A, that's A square, and force on C due to this D equal to Q square divided by A square. Okay. Magnitude are same, right? First we have to find the resultant, that is this one. FCD, F, which one? CD. Resultant between this one, that will be the F. Suppose we have to find the F. Resultant of this one, FR, this one. Then by using the principle of superposition, our resultant force between which one? FC and F. FCD and FCD. Then our root over how much? Both magnitude are same, that's why we can write the F. F square plus F square plus 2F into F cos. Now this time we have to take 90 degree. Because in the square that will be 90 degree. All angles are 90 degree in square. Okay. Then root over F2F square plus 2F square into cos 90, that is 0. That is what will be 0. Resultant force over here 2F square, that is F root 2. Resultant between these two force, we got F root 2, right? Okay. Then after that, here we have to observe there the direction of the force on C due to A going to this side. C. Okay. That means we have to F resultant force between this one FR plus FC. Then definitely we will get the total force, net force on C. Okay. First you have to write this one. Now net force equal to net force at C, okay, on C, that is the FR resultant force plus this one FCA resultant force our F root 2 plus force on C due to this one, okay. Then our it's Q square divided by, here distance we have to take this one, this distance AC, since our AC equal to Here on the square, that is a root over AC equal to root over a square plus a square, that is our this one, root over 2a square, a is cancelled out, that is a root 2. Okay, this one distance we have to use for this one, a root 2. Okay, in place of r. And then our force, net force on C equal to our F root 2 plus K Q for this one, A root 2 whole square. Okay, we can direct, you can use now. Here put the value of force over here. Our A Q square divided by A square into root 2 plus A Q square divided by A, that is A square into 2. Yes, then some term is going to cancel out, some term is going to common. Taking common, K Q square, then A square, K Q square. Then a root 2 plus our 1 by 2. This is the final answer according to this question. Okay, I hope you have to clear. Okay, whatever you have to clear, the doubts, whatever you will be doubt, then please write in my comments box. I will try to reply you whatever you have to problem. Okay, thanks for today's class.